What is ID3? ID3, Iterative Dichotomizer 3, is a decision tree algorithm developed by Ross Quinlan in the 1980s. It is primarily used for classification tasks and works by selecting features that provide a highest information gain. The algorithm recursively splits the dataset based on the attribute that maximizes information gain, creating a tree structure. Entropy and information gain. Entropy measures the disorder or uncertainty in the dataset. It is calculated as the sum of the probabilities of each class multiplied by the log of those probabilities. Information gain is the reduction in entropy after splitting the dataset on a particular attribute. The attribute with the highest information gain is chosen for splitting, as it provides the most significant reduction in uncertainty. Splitting strategy. ID3 splits the dataset based on the attribute with the highest information gain. This process is repeated recursively for each subset until all instances in a subset belong to the same class or no further splitting is possible. This results in a classification tree where each leaf node represents a class label. Limitations of ID3. ID3 works only with categorical data and cannot handle numerical features directly. It is also prone to overfitting if the tree becomes too deep, as it may capture noise in the training data. Additionally, ID3 does not support pruning, which makes it less flexible compared to other algorithms like CART. What is CART? CART, Classification and Regression Trees, is a decision tree algorithm developed by Bryman and his team in 1984. Unlike ID3, CART can handle both classification and regression tasks. It is a versatile algorithm that can work with both numerical and categorical data. Splitting strategy. CART uses Gini impurity for classification tasks and mean squared error, MSE, for regression tasks. Gini impurity measures the likelihood of an incorrect classification of a randomly chosen element, while MSE measures the average squared difference between the predicted and actual values in regression. Binary splits. CART always produces a binary tree, meaning each internal node has exactly 2 branches. This binary structure makes the tree more balanced and easier to prune, which helps in reducing overfitting. Advantages of CART. CART supports pruning, which is the process of removing branches that do not provide significant predictive power. Pruning helps in reducing overfitting and improving the generalization of the model. Additionally, CART can handle missing values more effectively than ID3. Type. ID3 is used only for classification tasks and cannot handle regression. CART, on the other hand, is versatile and can be used for both classification and regression tasks. Splitting criteria. ID3 uses information gain as the splitting criterion, which is based on entropy. CART uses Gini impurity for classification and mean squared error, MSE, for regression. Handling numerical features. ID3 does not support numerical data and requires categorical features. CART supports both numerical and categorical data, making it more flexible for real-world datasets. Tree structure. ID3 creates a multi-way tree, where each node can have multiple branches. Cart always creates a binary tree with exactly 2 branches per node, which simplifies the tree structure and makes it easier to prune. Overfitting prevention. ID3 is prone to overfitting, especially when the tree becomes too deep. Cart can be pruned to reduce overfitting, and it also handles missing values more effectively than ID3. In summary, ID3 is a great choice for simple classification tasks with categorical data, while Cart is a more versatile algorithm that supports numerical data and pruning. Understanding these differences helps in choosing the right decision tree for a given problem. That's all. I hope you found this video helpful. If you enjoyed it, please give it a thumbs up, subscribe to the channel, leave a comment, and share it with your friends. Your support means a lot. See you in the next video.